Okay, so today we're doing word problems. The basic steps, you want to identify the variable, like if you're using, x, what does x represent, or m, whatever it represents. Translates the words to algebra. So you got to take a, paragraph or a few sentences and kind of make an algebra expression or out of it. You probably use that equation to set up an equation. Typically, we're setting up equations, and then you're going to solve that equation. So that's the basic four-step plan to solve word problems. There's different types. So let's talk about this type. So it's kind of a linear thinking here. So like a fixed cost, like an initial value, kind of like a y-intercept there, plus a per hour charge, per minute charge, per day charge. That's an hourly rate or something like that. So um, this is a question about cell phone plans, which used to be set up a lot different than they are now. So this one charged you $30 per month plus 5 cents per minute every minute over the allotted 1,000 minutes. So what that means is the fixed cost is $30, right? It's every month, no matter what. Even if you don't use the phone, it costs $30, right? And you can talk up to 1,000 minutes, but once you get past 1,000 minutes, every minute over that is 5 cents a minute. So per charge type, so 5 cents a minute would be like oh 05 is 5 cents a minute, maybe something like that. Last month's bill came and it was for 43.50. So then you would have 43.5 that's equal to the total cost, right? 30 plus, and that kind of makes sense. You could almost solve this right now. In fact, um, well, I do want to solve this because something interesting happens. So if you subtract 30, you get 0.05. Equals, I guess that would be 33.5. And then you're going to divide by 0.05, divide by 0.05. And that's like multiplied by 20, but let's get our calculator out here. So 33.5 divided by 0.05. Okay, 33.5 divided by 0.05. I think I did that right. 670. So M equals 670. And so we never really established what M is. So M, every minute you go over 1,000 is, your minutes over, your overage. So I'm going to call M like your overage minutes, I guess. Overage, I'm not sure how to spell that. Minutes. So we went over 670. So how many minutes did we actually talk on our cell phone? To answer the question that was asked, you actually have to take the 1,000 minutes plus the overage, so 1,670. So sometimes with word problems, you have to make sure you actually answer the question that was asked. Maybe you expect it to be, how many minutes did you go over? But that wasn't the question they asked. They asked, how many minutes did you talk on your cell phone? So always answer the question that was asked. You might have a simple interest problem. So I stands for interest, P is the principal, that's how much you invest. R is the rate, always given as a decimal, and T is the time. So we're just going to plug into this equation. So interest is something the bank usually gives you for stuff, for putting money in there usually. She invests a portion of the money into certificates of deposit that earn 3%. She invests the rest of the money into another certificate of deposit that earns 4.5%. So let's just kind of think through this. So it says there's like the 3%, money that's put there. And then she also has the 4.5%. So 4.5%, covered up the decimal there. Okay. And that adds up to a total amount of $195.75. So this one's, you're going to have to think about this one. This is going to take a little bit of work here. So let's think this through. So big picture, I like to think big picture on stuff. So I'm going to say it this way. The interest you earn at 3% plus the interest you earn at, I guess, 4.5% is going to equal your total interest, okay, your interest total. So we know our total interest is 195.75. So you're really just going to plug in this equation. Well, Well, how do I figure out my interest at 3%? Well, fortunately, I have a formula for that, right? PRT. So we're going to use it. So we're going to say, okay, P is the principal. How much did she invest? I don't know. I'm going to define P is the principal for the 3%, 3% CD. Okay, so this is going to be P times the rate, which is 3%. Always write that as a decimal, times the time, which is it 1 year? After 1 year, yes. So times 1 is the time, it's measured in years, plus um, whatever amount she invested there, we'll talk about that in a second, times the rate, which is 0.045, and that's also 1 year, equals the interest total, which is definitely 195.75. And this is oftentimes the key to a word problem to figuring out. So you've got to figure out, like, it's kind of like, it actually reminds me of the segment addition postulate. I don't know if you've ever seen a problem like this in geometry. So it'd say this whole thing is 30. The distance from here to here is x. And then you say, well, what is the distance from here to here? And so it's the concept of the part plus the part equals a whole, but you kind of like do a reverse. And so, and many of you know how to do this. So you take the total or the whole minus the part. So this would actually be 30 minus x. Does that kind of make sense? You might have seen that in geometry class. The same thing applies here. So we actually do know the total of, she invests $5,000. So if P is $1,000 in the first investment, she would have 4,000 in the second. If P is 2,000, she have 3,000 in the second. So it's just split up different ways. We don't know. So I would say it's the total of 5,000 minus P. And so then you would just, at that point, solve this equation. So I showed my work. I did some of the multiplication in the calculator there, and I got P equals 1950. Of course, the question asks how much did she invest at each amount. So this one was at the 3% investment. And then if you do, I guess it'd be 5,000 minus 1950 is $3,050 at the 4.5% level. And so you can figure it out that way. You had to set up the equation and solve. So mixture problem. So you've got lima beans, which I don't know why anyone would eat lima beans, but lima beans and corn, and you're mixing them together to make this beautiful vegetable medley. So I like to do this in a very visual way. I usually just draw a picture of like a soup can kind of thing, plus another soup can or a vat here is going to equal our total here. So I like to put all my information and kind of organize it almost by color here. So like this one was what, 90 cents a pound. So the lima beans was 0.90, 0.9 for the lima. And the corn was 50 cents a pound, so 0.5 for the corn. Add those together to get our mixture. Sorry. And this is 0.65. And then the cost, 16 pounds of corn. So we do know it has 16 pounds of corn. So 16, I guess LBS here, 16 pounds of corn. So, boy, we don't really know the other information here. You have to kind of infer, okay, well, we don't know how much lima beans, so I'm going to say X. If we wanted to define X, X is the number of pounds of lima beans. Then the mixture would contain a total amount of X plus 16 pounds, right? So you've pretty much got all the information there. It's real visual. And at this point, it's pretty easy to set up an equation, I think. So to figure out how much lima beans, you take the cost times the number of pounds. So it would just be 0.9 x plus, the equation says plus, the cost per pound for corn times the number of pounds, so 0.5 times 16 equals the cost times the number of pounds, so 0.65 times x plus 16. You're just going to solve that problem. You solve that and you get x equals 9.6. Just see what the question asks for. So it says, how many pounds of lima beans? So that's 9.6 pounds would be the answer. 9.6 pounds. You would add the units there in that case. Let's look at one more problem. So distance, rate, and time. I call this DIRT. The DIRT formula, D equals RT, almost as like the word dirt. So I like to draw these out. Typically when I have a question like this, I'll kind of draw it and see what that kind of looks like. So let's see. So Bill left his house at 2, rode his bicycle. So, he's at his house. He kind of rode his bicycle this direction for a while. He left at 2 p.m. And he went 12 miles an hour. And he kept going, right? And then Mary left the same place. And she's pedaling for a while. And she's going at a faster speed, I think. Let's see. She's going 16 miles per hour. And she left at 2:10, so she left just a little bit later. So, but eventually they caught up, right? So they did eventually kind of like, you know, meet together. She caught up and they were at the same level. And what time did Mary catch Bill? So it's all about the time here. And so we're going to do distance, rate, time. So this is kind of like um, you could. So usually sometimes you'll have like distance plus a distance equals total distance. It's not really the case here. We don't really even know the distance, but we know the distances are equal. So the big concept here might be, let's see if this works, distance of Bill equal distance of Mary. So I think we could set up an equation like that. Let's try that. Those two things should be equal. They went the same distance. So rate times time is our formula. So rate would be, let's see, Bill's rate is 12 times his time. And we don't know what his time is. I'm just going to say t equals Mary's rate, which is 16, times her time, which is 10 minutes less than Bill's. But you really have to think about this because if you notice, like this is kind of subtle, but it's miles per hour. This is 12 miles per hour, 60 miles per hour, and it's 10 minutes. So you have to convert one way or the other. I think I'm just going to convert the time. So 10 minutes is like 1/6 of an hour, 10/60ths, right? So 1/6. So this would be t minus 1/6. And now we have our equation, and you can just solve that equation, and we should have it. So I kept solving. I got t equals 8/12, which is, I guess that's 2/3. 4 goes in there. So 2/3 of an hour. So at what time did Mary catch Bill? So 2/3 of an hour at 20 minutes. And 2/3 of an hour is 40 minutes, right? That's 2/3 of an hour. 20 minutes is a third. So 40 minutes from the time, that's Bill's time. So from 2, so it would be 2:40. Be the time that they caught up with each other. So that's that question. And you'll have some others. I didn't cover maybe every possible type of question, but those are some of the big types. Some you just got to figure out. Sometimes it's kind of a riddle, and you've got to just kind of set up your equation. Again, define your variables. In this case, the t was the time that it took for Mary to catch up with Bill. So define your variables, even if you don't need a formula. Sometimes it helps to use meaningful variables like m, for miles, or use some meaningful variables, and that helps a little bit at times. That's it.